We're on to graphing exponentials and logarithmic functions. In this lesson, we're going to look at how to graph functions using your calculator and the table mode on your calculator. And we're going to look at solving some problems involving exponential and log functions, so fairly typical exam style questions. So exponential and log graphs, you can see here the graph of y is equal to 2 to the x. That's an exponential function. The x is a power. We then have this log function, log base 2. Now you'll notice that if we've got y is equal to 2 to the x and log of x base 2, they are the reflection of each other in the line y is equal to x. Now, whenever graphs are a reflection of each other across the line y is equal to x, they're inverse functions. So we already discussed how ln and e are inverse of each other, and in general, exponential and logs are kind of two sides of the same coin. So we've got a 2 to the x and log base 2 being the inverse of each other. Over here, we've got the graph of e to the x, and we've got the graph of ln of x. The red is e to the x, the blue is ln of x, and they are the inverse of each other across the line y is equal to x. Now we're going to look at plotting these graphs and other types of graphs in our calculator first thing. So I'm looking at two types of calculators. I have got this one here is the newer one that students are buying in the last few years. It's quite a change from the old one. So any student who's got this new calculator, there have been a lot of changes and it might be a bit confusing to get the hang of it. Before this model, any of the previous calculators for a good few years beforehand are all very similar. So if you've got the newest one, I'll show you. And then if you've got any other one, you'll be able to figure out what to do based on what I show you on my other calculator. We're going to use these functions, which are not log or exponential functions, but we're going to use these to figure out how to graph functions using our calculator. So this graph is y is equal to 3 over 10 x cubed minus 2x. So it's a cubic graph because the highest power of x is 3. That's the x cubed term there. So usually in these exam questions, they will already pre-fill some of the table, and that's a really useful way for you to check on your calculator that you've done it correct. Very often in exams, they'll also leave you space here for working, and sometimes students think that they have to show the substitution because there's space for it. You don't. You can literally just plug it into your calculator and I will show you how. And then we've got to draw the graph. So I'm going to switch across now and show you how to do that on the calculators. Let's start with this newer calculator. So this is the one that you'll have if you bought one in the last couple of years. So this is, we're in our normal run mode. If I press home, we can see our options. Calculate is where we spend most of our time. Let's now go into table. So here I've got a table of values, which is a vertical version of the horizontal table that I've got in my exam question. The fact that it's in a different orientation hopefully won't throw us, but this table is blank. I need to put in some x values, but I don't know what y values or what f of x values are going to come out. I haven't typed my function into this calculator yet, so I need to do that. So if I press this button here, f of x, that'll allow me to type in my function. Now I'm going to come down here because the calculator is saying here, define f of x. The calculator wants me to tell it what f of x is. So define f of x, execute. Now if there's a function in here already from the previous time you used it, you can just delete it. And let's type in our function. So our function f of x is 3 fraction 10 x cubed. Now the x is up here. And to get the power, we use this button here. X cubed, use an arrow to get out of that, minus 2x, execute. So I've still got a blank table, but the function is hiding there in the background. And if I type in my x values, it will tell me what my outputs, my y values, or my f of x values are. So the first x value on the table is minus 3. Now this button here, that's subtract. So it's not what we use for negative. Can you see above it in blue? In blue, that's the negative. So in order to get that, I'll press Shift minus. So minus 3, and you can see it's giving me the output, the y value. The next one is minus 2, Shift minus 2. Now be careful with the next one because it's minus 1.5. So do keep an eye on what you're doing here. Minus 1.5. And next is minus 1. And we'll keep going like that. 0, 1. 1.5, 2, 3. Now, what we're going to do is we're going to just double check with the values that they gave us already pre-filled to make sure we're on the right track. So minus 1.5 should have an output of 2. It does if you round it off. So we better check another one to see if we're okay. Minus 1 should be 1.7. Yes, it is. And 1.5 should be minus 2. Yes, so there's a little bit of rounding gone on here. So we've rounded to 1 decimal place. But so if we round our values to 1 decimal place, we should be okay. So now we've got these points, and these are the points that we're going to plot. X coordinate, Y coordinate. We're going to plot all of these points. So now let me show you how to do it if you've got one of these older calculators. Any of the previous few generations of calculators are similar. Even if your calculator looks slightly different, you'll probably be able to follow these steps. Right, so we're going to start by going into menu, and we've got all of our options here. If I scroll down to option number 9, table, and press equals, it'll take me in there. It's asking me to type in my function, 3/10, come out of the fraction. Now the x in this calculator is above the bracket in red. If you want to get anything in red in this calculator, you've got to press alpha. So alpha, x, and it's x cubed. There's my power button. X cubed, come out of that power. Minus 2x, minus 2 alpha x equals. Now g of x, it's asking me, would I like to put in another function? And I would not. I'm only doing one, so I'll just press equals out of that. Table range, it starts at minus 3 and it ends in 3. Step. Now, be careful with this, because at first glance it looks like it's going up in ones. Minus 3, minus 2. But then it goes up in 0.5s. So what I would do here is, if you set your step at 0.5s, it's going to go up in halves, in a half a unit, and you can just pick which values you need from the table then afterwards. Let me show you what I mean. So I'm choosing my step as 0.5, and it generates the table for me here. So minus 3, x of minus 3 is y of minus 2.1. Let's do that check again. So if I go to minus 1.5, I should have an output of 2.0, which again, once I round, I do, and check for 0, minus 1 should be 1.7, and it is 0, 0, and 1.5 minus 2. So we'll write in the rest of these values into the table, and again, you won't need all of them, so be careful. You're going to write in the minus 3 value. You're not going to write in this y value when x is minus 2.5, because we're not asked for it in the question. We do want to write in the y value for x is minus 2. To get back out of that, press menu and back up to number 1, calculate. On the grid, draw the graph. Now, these questions tend to have a lot of marks going for them. And given that you don't have to show working, given that it's really your calculator doing the work, they're a very, very good question for you to make sure you're strong on. So I've got to draw the graph from minus 3 to 3. Minus 3 is minus 2.1. Minus 3 on the x to minus 2. Oh, what's the scale? 1, 2, 3, 4. There's 10 boxes here for 1 unit. So each of these is going to be 0.1. Likewise on the x-axis, 10 boxes here, 10 squares for 1 unit. So each square is going to be worth 0.1. This is a cubic graph. So I was expecting this kind of roller coaster, which I've got. You must not use a ruler to join up your points. Just join them up one at a time. Don't do this arty, feathery line business either. There we go. Nice cubic graph. Right, then there's a little question to go with it at the bottom. On the grid, draw a suitable straight line to solve the equation 3 over 10x cubed minus 2x. Now, this is the graph that we have drawn. This is our graph. And we want to know, when is it equal to this? Now, we don't have a picture for this, but it tells us to draw a suitable straight line. I want to know where my cubic graph, this is our cubic graph, is equal to this, which is a straight line graph. I'm going to need to draw this graph. So what I'm going to do is I'll take it out here on the side so I'll have a bit of space. I want to draw the graph of y is equal to a half 1 minus x. I've already drawn the graph of y is equal to 3 over 10x cubed minus 2x. So let's multiply out that bracket first thing so we can see what we're dealing with. So it's a straight line. So I'm thinking y equals mx plus c, but I like to have my x term first. So I'm just going to swap these around. Now I'm thinking y equals mx plus c. So c, our y-intercept, is a half. So a half is there. And m, our gradient, is minus a half. If I just come out here and show you that, if m is minus a half, we know that gradient is rise over run. So that tells us that our rise is 1 and our run is 2, but there's a minus there, so be careful. Instead of a rise, it's actually a fall. So I'm going to run along 2 and run down 1. Now watch the scale. I'm up at a half, so I've got to go down to minus a half. So there it is. Now if I join up these dots, that's going to give me my line. I'll just keep going, fill up the space that I have. It tells me to do it from -3 to 3, so I better fill up the full -3 to 3 graph. Now, if I want to draw a little bit of my line over here on the left, I'm going to need to do the opposite steps. So I did run along 2 and drop down 1. So backwards of that is run backwards 2 and rise up 1, which I think would take me to here. So let's join up those dots. It can be a bit of a wonky line, but that should be it. I've drawn my line. It says, draw a suitable straight line, solve the equation. Now, what we've got here is a curve equals a line. Where is it the curve equal to the line? At the points of intersection. Where are the points of intersection? The points of intersection are here, here, and here. Now, you will be allowed a little bit of flexibility here to be a bit above or a little bit below. So x is equal to, this value here looks like it's at -2. I only want the x values. This here looks like it is at -0. I'm going to say -0.4. And this one is at, I'm going to say 2.4. And again, you'd be allowed a little bit of flexibility there. Right, there's more. For -3 to 3, so that's the full space of the graph that we have, the equation 3 over 10 x cubed minus 2x is equal to 1 has n solutions. N? Write down the value of n. Now again, isn't this our curve? Yeah, it is. This is our curve. And we're told the curve is equal to 1. So where is our curve equal to 1? So we want to know where our curve intersects the line y is equal to 1. So I'll go back up again and I'm going to draw the line y is equal to 1. The line y is equal to 1 is the line that has every single y coordinate on it is 1. So it's this line here. This is the line y is equal to 1. And we're told the equation curve equals line has n solutions. Now the curve equals to the line here, here, be careful there, make sure I pick out the right graphs. There's a lot going on here, and here. So how many solutions does it have? It's not asking me to find the solutions. It's just asking me how often does the curve cross that line? It has 3 solutions, those 3 yellow highlighted points. All right, that's the end of that question. Right, so here's a question that I want you to do now. It's very similar to the question that I've already done. You have your table of values with some pre-filled. It's a cubic graph, so you get that nice roller coaster up, down, up happening again. Draw the graph from -3 to 3. And you're being asked to solve. Now, let me see. Is this my curve? Yep. Where is the curve equal to 0? Now, think about where that is going to be. What line? We're looking for the point of intersection of the curve and which line. And then it's saying the largest value of integer k. This looks confusing. This is my curve here still. The curve is equal to, now think about that k. It's very similar to what we did on the previous section. It has 3 solutions. So my curve and this line are going to intersect each other 3 times. What's the largest value that number can be so that it's got 3 points of intersection? Pause and have a little go at that. Right, so hopefully you got on okay with that. We got a nice little graph out of it, and that last question there was slightly different and a little bit interesting. All right, one more question then. In this video, we're still graphing functions using the calculator. A clothing company sells t-shirts. The daily sales of t-shirts over 360 days can be modeled using the function t of x, where x goes from 0 to 360 and it's a real number. And then there's this unpleasant looking function. Fill in the table below. Once again, I'm not going to be subbing any values in. I'm literally going to pop this straight into my calculator. So f of x, I'm going to put bracket and then fraction inside the bracket. Find my x, minus 240, down to the bottom of the fraction, over 60, out of the fraction, close the bracket, cubed. There we go. Plus 70. I don't have any second function. My start is 0 and my end is 360. What do I want to go up in? 0, 60, 120. It's going up in 60s all the way, isn't it? So my step is going to be 60. And those are my values. 0, 6, 60, 43. There's my check. That works out. 120, 62, 180, 69. Scroll down using the arrows. 240, 70, 371, and do the final check. 360, 78. Perfect. Draw the graph. Down here, 0, 6, 60, 43, 120, 62, 180, 69, 240, 70, 371, and 360, 78. So what are we measuring here? Daily sales of t-shirts. So for the first 60 days, the sales rocketed. But then they started to level out. So I'm not sure how well sales are going for this company. Now, in a typical exam question, this would be the first part. There'd be more questions where you would have to apply your skills after that. So here we were looking at just how to use the calculator. In the next video in this lesson, we're going to be looking at graphing specifically log and exponential functions.